All right, so our last speaker is Josh Portlock. He hails from Perth, Australia, which is at least from DC, the furthest point on Earth. And so I appreciate you coming all this way. So Josh is the CEO and founder of ElectroAero, as well as innovative director of Fly on E, and half a dozen other companies he keeps busy that he's co-founded. He brings 2 decades of expertise in development and commercialization of electric propulsion and autonomous systems. As an entrepreneur and a robotics engineer, Josh has specialized in electric propulsion technologies and is a leader in multidisciplinary design optimized aerodynamics, control systems, and sustainable innovations. Josh's achievements, so Josh is brilliant, he's a genius. He's presented at TEDx Perth. He's been recognized as a Holland IQ's top 100 climate tech companies in Australia and New Zealand, Anthil's top Smart 100, winning Curtin Alumni's Innovation Award, Global Recognition Award in 2025, and APAC Entrepreneur of the Year Award in 2025. So we're really glad to have you, Josh. Come on up, and thank you.
Great, thanks for having me. Last but hopefully not least, right? I'll bring some of my Australian charm to keep you awake. So yeah, we're really proud of leading the charging industry for electric aviation. We've been at it for over a decade now, so founded in 2014. And in that time, we've really been working closely with so many airframers that we've learned an immense amount about the industry through real world school of hard knocks. Just make sure this gets on. And what I really wanted to share with you is what not to do. Like, don't just copy the automotive industry. Aerospace is different, and I want to talk about the reasons why. So there's really been a poor global standardization of automotive charging standards. There's at least half a dozen different car charging standards out there. And yes, they're at least the same-ish in each country, if not like 2 competing at any one time. But you then go to export that car to another country, you have to completely change the inlet, the physical inlet, as well as the software protocol, and there's compatibility issues. And it's just plagued the automotive industry. And it's fine when you've got 500 plus engineers in the charging department of your automotive company, but when you've got like 1 or 2 engineers in the charging department of an aerospace company, that's a lot of work for us aviation developers. And it's really been unreliable and inefficient to use adapters, so we really want to avoid that. And the EV charging business models haven't been great either. The economic viability of public car charging has actually been really poor. The only reason Tesla has done so well is brute force and ignorance through a huge amount of capital raising to make such a reliable supercharging network. But almost every other charging network has been unreliable, plagued with inefficiencies and unprofitability because of the low utilization. So when you factor all these things in, let's just not make the same mistakes as the automotive industry and take aviation charging a lot more serious. And a few other comparisons. So cars are pretty nice and compact. They can just pull right up against these stationary vertical chargers with short cables, relatively short cables, where aircraft have these much larger wingspans, and we have to factor in that they often have multiple inlets. Just like when you're refueling in a Cessna, there's a left and a right wing fuel tank. There's typically left and right batteries as well, and you want to be able to charge them directly and not have huge cable weights on board the aircraft to go from one inlet as the bottleneck to charge all these distributed batteries. Their cars can park close, they have big wingspans. Cars also charge sporadically, opportunistically. So what I mean by that is, you get hundreds of miles of range these days, so you only need to charge every other day at best. And you're mostly charging at home as well, so it's really occasionally you're going to charge at a supercharging network, where aircraft need to DC fast charge every single flight to make sure that reserve is topped up and that you're satisfying your FAA and aviation regulatory reserves. Lastly, you really can't justify the weight of an onboard liquid cooling system for aircraft. Now, some are exploring that, but the majority of them, the really well-optimized solutions, are looking at off-board liquid cooling. Now, this is the biggest factor that makes aviation charging completely different to automotive charging, whereas you're adding about 50% more weight to the cell weight by adding liquid cooling on board a car, and it's justified because the cars need to drive all day and charge sporadically, as I said, so they've got to keep those batteries cool for maximum life cycle. If you're charging every single flight, you can cool them every single flight too. So you can cool your batteries off board while charging, get them down to a low temperature right before that flight, so that the thermal inertia of the battery doesn't even get too hot. By the time you've done your 10, 20, 30-minute flight, the batteries have gotten warm but not molten, and then you can cool them back down on the next charge cycle. So these are factors that make aviation charging quite different to automotive. Last points I'll make is, if you try to just plop car chargers at airports, they're very impractical because they were designed to be vertical and compact in an X and Y, but tall in a Z. That's really annoying at airfields if you're trying to deal with these 50-foot wingspans and you're worried about hanger rash and cable lengths and stuff like that. So while we did see some people install car chargers at airports and say that they were aircraft chargers, they haven't been utilised because they're just not very practical. They typically have all those compatibility problems I mentioned. Cable lengths aren't typically long enough. Usually 3 meters is what you typically see on a car charger. You need more like 20 meters to really be versatile for every possible airframe configuration. And supporting advanced software features like scheduling for aviation flight rather than an unscheduled car charging service. And they're not modular and upgradable for future changes in the rapidly changing space of aviation. So we've been actually doing this for over a decade, but shipping portable chargers for 8 years now. Archer, our friends here, have been using, and Ampere have been using our chargers for quite a while. So while we couldn't talk about the stuff with Archer for a long time, we have been charging all their prototypes to date. So don't read everything you see in the news. We've actually been charging the majority of their flights. And same with Ampere all over the UK and to Scotland and back and all over California. So even the hybrid aircraft like Ampere have benefited from our charging solutions to get those batteries topped back up. And for Archer, the versatility of our solutions being portable has allowed them to move different locations quickly and use up to 6 of our 80 kilowatt chargers to charge their 6 individual batteries at high speed directly and minimize cable weight in the prototyping phase. We've also been flying electric aircraft ourselves since 2017, so we were the first to get the ElectroAero certified for commercial operations, not just in Australia but in the world, and we've been racking up thousands of flight hours commercially and learning the challenges of charging. And this is really what drove me to get more into charging, because it was great having the world's first electric aircraft with one charger at one airport, but you couldn't go anywhere. And we even tried to pilot on the back of a ute, or a truck as they call them here, and drive it to another airfield, but there was no power that was powerful enough to plug it in, so we had to tow a trailer of a diesel generator, and we towed that there and felt really embarrassed to charge our electric aircraft off a diesel generator. But the most embarrassing part is it was so hot that day, like 40 degrees ambient, the diesel generator couldn't even keep up with the power requirements and it was tripping out. So we had to throttle down the charger, and we were just there going, wow, charging infrastructure is a really important thing for aviation to be well adopted electrically. So yeah, since then we've been developing the really key components of aviation charging. So not just the portable chargers, which have been really our bread and butter, but the onboard control electronics for the airframes, as well as these portable battery energy storage solutions to be buffers when there isn't enough power at an airfield, which is almost always. And it's progressively, the amount of power needed is getting higher and higher as these aircraft get more powerful, and the amount of power at the airports is still the same. It was only ever lighting and maybe air conditioning that they were ever designed for, not hundreds of kilowatts per aircraft. So these battery energy storage systems act as buffers, and you'd be surprised, even with like a 208 three-phase relatively low power connection, you're still bringing in like tens of kilowatts continuously and then sporadically charging your aircraft. So you can basically take in a low amount of power continuously into one of these batteries and then fast charge an aircraft when needed, and then you've got the time in between to top back up again. So it does really work just fine with it, and it's way cheaper to add a battery energy storage system as a buffer than spend a lot of money, wait a long time, get the upgraded power, only to pay the privilege of a higher power demand charge. So once you've actually paid for a bigger connection, you actually start paying more for the energy too. So the irony of that's not lost on me. So you invest in a battery and ideally a solar system, and you're actually starting to be your own power plant. So it's far better to upgrade your airport with solar battery solutions than bigger grid connections. So I wish I could show you the dozens of aircraft we've been providing chargers to, but these are the 4 that have signed public disclosure documents of what we're allowed to say we've done for them. AirView, one of our great partners here, have been doing some great work using our 6968 standard and our onboard charge control unit. Archer, we've been charging for over 6 years now, from when they were stealth mode, from the 2-seat prototype through the 5-seat flight campaign. They've recently moved to 1 CCS charger for their most recent prototype, so we are able to support that too. But the 6968 standard has proven to be extremely robust. We've never been the reason they have not continued with flight testing, and they've always appreciated that we've had a very good reliability rating on all our chargers to keep them flying. Ampere, as I mentioned, great partners here, and even though they're hybrid, they're often parallel hybrids, so it is beneficial to still charge that battery every flight. In some of the other configurations it's not needed, but it is still always more cost efficient to put electricity in, even from the grid, is going to be cheaper than onboard generation, so from gas or even especially from SAF. And Jumpero, Carl's here before, I don't know if he's still here, but Carl's doing some great work. We've been supporting him for over 4 years as well, so we're his preferred charger provider and onboard charge control units, and that's been a great program and perfect fit for our really compact high performance chargers. Lots of great partners as well. I don't have too much time, don't want to keep everyone from dinner, but we have some really great partners in the development and operations and rollout of our charging solutions. And I wanted to talk about how important it is that the mobility of the charger, or the end effector if you want, the dispenser of the plug, should be portable. Because while it's all well and good to drag 10 meters plus of cable out onto the tarmac, you're going to have wear and tear issues, and we've seen this over the years in the automotive industry and even in our experience. The cables do wear out, especially on 40-degree days where the ambient temperature of the tarmac is like 60 degrees and it's sharp, bitumen. You're basically asking for trouble dragging a rubber cable out over high temperature, sharp bitumen. So we are all about getting the cable off the ground, off the tarmac, and this is Z-arm, or in Australia we like to call it the crocodile arm, or alligator arm for you Americans. And the fact that it can keep the cable off the hot tarmac, protected under the white cover, so you're not getting direct heat from the sun with the white covered arm, you're not getting the radiant heat from the tarmac, and you're not wearing and tearing the cable. So instead of maybe 10 meters of dragging a really heavy cable and wearing it out, we're getting tens of meters of very low cable wear and tear, and ease of maneuverability to the dispenser, and then the last few meters of the cable can still be reached around from the dispenser. So single person operator is really important. We actually think most of these AAM operations will be single pilot, single fueling operator all in one. So it's likely the pilot will get out, go get the charger, plug it in. It's actually far more time and cost effective for that pilot to go and grab the charger and bring it to the aircraft than for him to try and taxi, waste energy moving the aircraft around. Onboard energy is very precious, so you're far better off moving the charger to the aircraft rather than the aircraft to the charger. So what's the latest in charging standards? So while we've been pushing and promoting the EAS2025 standard for SAE that we started almost 7 years ago now, we are receptive to the fact that CCS1's a safe, easy bet for automotive adoption in the US, CCS2 in Europe, CHAdeMO in Japan and neighboring countries. So we're agnostic to what coupler we put on our chargers. We just recommend that the best one is 6968. So we don't want to be precluded from supporting portable chargers for people who have made the mistake of picking a car charging standard, but we're happy to transition to 6968 over time. The megawatt charging is also under development under the code 7357, and that's likely to be feasible after 2028, so don't hold your breath, but it is looking like it's progressing. It is based on the MCS standard for automotive, so it is at least physically compatible, but it will actually have some software and electrical differences. And then Joby have their GAX coupler, so the General Electric Aircraft Charging Standard, kind of the Tesla NACS of the aviation industry, if you will. By the way, no one is using Tesla NACS for aviation. I found that quite interesting to watch, but I'll maybe comment on that at the end if I have time. What I do like about GAX, I'll give them a lot of credit because they weren't able to make it here, who's going to be speaking before me, and Paul Guerrero has been doing a great job with his team on integrating liquid cooling and dual plug power all in one coupler, and it is a work of art. but it does have its cost and complexity trade-off. So while it's great for their very specific use case of high performance dual battery active liquid cooling, it's not as universally acceptable as other aircraft would need. So we are catering for both GX on our chargers and 6968 or CCS1, and we can provide any combination that people want. But what we're also doing is working on a more universal off-board battery thermal management standard within the AE70 committee called AIRs-8487. These are all a mouthful of acronyms, I'm sorry, but the 8487 standard is a combination of actually work from Joby, Beta, Archer and ourselves, and a few other airframers getting involved to standardize the method of off-board liquid cooling. So even though Joby have committed to integrating in the plug, Beta are committed to integrating in a standalone plug separate to the CCS1 charging coupler, we're making sure that everything back from that liquid coupler is standardized. So the type of fluid, the pressure, the flow rates, the volumes are catering for all the different aircraft in the foreseeable future to make sure that we have one dispenser that can have different plugs on the end and still charge and actively liquid cool these different aircraft. So you can imagine it's not quite as easy as you'd like, but I like a good challenge. I'm a sucker for punishment, so we are trying to standardize for as many electric aircraft as possible. And why not CCS? I'm going to hammer this home, is that it was designed for car charging, and cars are not aircraft. So they don't work outside the horizontal orientation, and almost all aircraft with batteries in the wings want to plug up vertically. So they actually hang out of the wing, and you actually don't get as much DC coupling because the clips at the top of CCS1, and you have to add another latch, another lock, and you have to be holding it up while it's locking. So there's all sorts of reasons why it's bad for wing charging. And then the bigger inlets, I've got the inlets here, I can show you the 6968 inlets, very compact. We don't need the AC pins because they're just dead weight. You're not going to justify an AC to DC converter on board an aircraft anytime soon, but with a car you can justify it for level 1 and 2 charging. We use 28 volt auxiliary power in our coupler, so you actually can charge the auxiliary battery and undersize your DC to DC onboard hardware, so that saves both cost, weight and volume. PLC is really noisy. It's only ever originally designed for 3 meter cables, not 10 plus meter cables, and it definitely can't handle the megawatt levels of power. Small DC pins, so the CCS1 and 2 are only 8.5 mil pins. They get molten hot above 180 degrees, and we can handle above 180 amps, they get molten hot. We can handle 250 amps without liquid cooling the coupler. They can handle up to 500 amps, but they need really active liquid cooling to cool the pins. We can handle up to 650 amps with the same level of liquid cooling. So that extra sort of 20% margin of current without liquid cooling or with liquid cooling does make a big difference to just get that extra more energy in. The lock mechanism of the 6968 standard is on the plug. So that's something that's lower cost, it's physically portable, serviceable, repairable without a full STC work order from a LAMI. So you don't want to have any complex maintenance on board the aircraft for the charge coupler, you're keeping that off board. And the most obvious fact that everyone's ignoring when there's a press release, oh, someone's adopted CCS. Well, which one? CCS1 or CCS2? Because there's literally people flying CCS1 aircraft in the US and can't plug into the CCS2 chargers, vice versa. The couplers are actually outlawed as dangerous, so if you put any more than 150, 180 amps through these couplers, they can melt. So it's just lots of reasons we should avoid CCS1 and 2 long term, but I kind of respect why they're doing it first, because it's off-the-shelf car components that they can plug and play and prototype test. But pre-certification, that's fine, use whatever's readily available. Post-certification, we should really try and standardize. Sorry to harp on about that too much, but just to emphasize, we're a one-stop shop for charging solutions for airframers and now for FBOs too. So while we've supported airframers extensively over the last 6-8 years, now we're really moving to supporting the FBOs with their selection of chargers, and we assess the amount of power they have at the airports, let them know if they are better off putting containerized batteries in instead of upgrading the grid, and we can support the upgrade, the progressive upgrade of power from like 40, 80, 240, 640 kilowatts and so on. Conscious of time, so I've got to wrap this up, but the 240s are really good all-rounder all integrated AC to DC converting charger, plugs directly into AC outlets or a containerized battery, and means you don't need to have any fixed infrastructure other than possibly having big outlets installed on the wall or even on the ground. The 640 kilowatt was originally designed for Lilium, to be honest, rest in peace, because that was the amount of power they were wanting to charge their large battery at. No one else is actually needing that yet, but it is very future-proof. So we can run dual 320 kilowatt plugs off that, or a sync, so CCS 1 or 2 can only do 320 kilowatts each, where the 6968 standard can do 640 kilowatts in one coupler. So that's a real big improvement. And then with GAX, we can do 2 GAXs for Joby of the one 640 kilowatt dispenser with the active liquid cooling as well, up to 22 meters of Z-arm, crocodile arm, and that allows you to go all the way around the back of an aircraft. And the reason that's important is you have ingress and people coming in and out of the aircraft, both sides of all these aircraft. So you don't really want any cables to trip over. So you always want to bring the dispenser around the back of the aircraft and bring the charging cables to the wings or the fuselage and allow people to get in and out of the aircraft without tripping over cables. So we've thought a lot about these things and really trying to future-proof for any layout of airframe. So I'll whiz through these different layouts, whether you're plugging into the fuselage, the wings, you can always get the aircraft, the charger around to the back like this example for a Joby layout, and plug into the wings and still allow full uninterrupted access. So I'm conscious of time. I have a video to play while I talk about Fly on E, but we really want to be the building blocks of the airports in the future. Make sure we can support these containerized batteries as grid buffers and run more off renewable energy, and make sure that you're never going to have a bottleneck or a charging problem at airports in the future. So thanks for your time. That's a summary of how we want to be a one-stop shop for both airframers and FBOs. And this next section is Fly on E, our sister company where we're operating electric aircraft for over 6 years commercially now. And we've just closed an IPO round to go public, so it's pretty exciting times for the company. If you can change to the video, please. We'll just play it on loop so I can explain what we're doing there. So I'm sort of squeezing a little two-in-one here, but that was ElectroAero, and then this video is about Fly on E. So the Alpha Electro has been our main bread and butter operations for the last 6 years, and that's been great. We've learned a lot from that, a lot about active battery management, cooling, and charging. And we're partnered with Airventure to start operating those commercially as well. About half a dozen airframers I could talk about. By Aerospace are great partners of ours. We've had their airframes on order for a while to operate longer range flight training. And the most exciting thing about CASA in Australia that I'll boast about is that they've been very receptive to working with us. If you can loop that, just keep playing it. They've been very receptive to work with us on adopting these new aircraft. So if you just loop that video one more time, and I'll just summarize in saying so the great thing about Australia and CASA, and I'd encourage all airframers to take this into account, is that CASA have been very receptive to commercially driven regulations. And we've been at the forefront of that. My background in drones before this, we were the leaders of unmanned aircraft flight training 15 years ago now. So we were operating 7 years ahead of the regulations in the US. And we're seeing that head start. We've had 6 years of head start with the Alpha Electro, and we think we're going to have about a 5-year head start on general aviation operations. We recently bought Rottnest Air Taxi, which operates the Cessna 172s and Cherokee 6s to fly to and from Rottnest Island. It's only a 12 to 15 minute flight, so very suitable for electric aircraft. And we do encourage all airframers and all operators to consider Australia as a great place to partner with us on commercialising your aircraft. And feel free to follow up. Come see us at the Buy Aerospace stand on Tuesday at 11 a.m. for an exciting announcement. And we look forward to liaising more with you throughout this afternoon's catch up too. Thanks for your time.